Hi everyone, I am Dr. Bharathi, Assistant Professor from Department of Computer Science PG, Kristu Jayanti College, Bengaluru. And today we are going to discuss about an interesting session on the image classification. So, image classification is a fundamental task in computer vision that deals with automatically understanding the content of an image. So, it involves assigning a category or label to an entire image based on its visual content. So this makes use of the plenty of images and captures and analyzes the understanding the content of an image, what visually it represents. Next, coming down, the breakdown of the concept of the image classification. So the first step is going to be on assigning labels. So the goal is to analyze an image and categorize it according to predefined classes. So imagine sorting photos into folders like cats, dogs and mountains. The image classification automates this process using computer algorithms. So understanding the visual content is going to be the second concept, where this algorithm goes beyond just recognizing the shapes and colors. The first step was the assigning the labels, and second one is going to be the understand the visual content. So the visual content is going to be recognizing the shapes and colors. So this is going to be feature extractions. So this concept of understanding visual content extracts the features from the image like edges, textures and patterns to identify the objects or the scene depicted. And next, we're coming to the third concept is on training on examples. So to achieve this, image classification models are trained on massive data sets of labeled images. So these data sets help the model learn the characteristics of different categories. So the image classification models should have a big and huge massive data sets of the labeled images. And now coming back, we have different types of the image classification, and first one is going to be the binary classification. So as the name indicates, the binary classification is going to be determining whether an image contains a cat or a dog, or the cat or not. So it is the simplest and basic means of the image classification. And second type is going to be multi-class classification, where it categorizes images into more than two classes. So for instance, the classifying images of different types of the animals. So you have different types within the image, and you're going to categorize whether that image is going to be on cats or dogs or birds. So each image is assigned to one and only one category. So this is going to be on multi-class classification. And the next one is going to be on multi-label classification, where it allows an image to be associated with multiple labels. So for example, so an image might be classified as both sunset and beach. It is very difficult to decide whether the image is on the sunset or the beach. So this type of classification is useful when images can belong to multiple categories simultaneously. And the next one is going to be hierarchical classification. So this involves in classifying images at multiple levels of the hierarchy. So for example, an image of an animal can first be classified as a mammal and further be classified as a cat or dog. So this method is useful when dealing with complex data sets with multiple levels of categories. So the first is going to be the classification on the mammals. The second classification, and it's going to be on next hierarchy, is going to be on either it could be on cat or a dog. And the next is the fine grained classification. So here we are going to classify different species of birds or breeds or dogs. So this type of classification requires high resolution images and the sophisticated models to capture the subtle difference. Even the minute differences also should be captured. For that we require a high resolution and images. So for that, the fine-grained classification focuses on the distinguishing between very similar categories. And next one is going to be few-shot classification, where the model is trying to classify images with only a few examples of each category. So this is useful in scenarios where obtaining a large number of labeled images is quite challenging. So now we have discussed different types of image classification. Now we are going to discuss the difference between the image classification versus object detection. So as we have seen, the image classification is the classifying that particular animal. So the first picture represents the image classification where it is classified. The image is classified as a cat. And the second picture, which represents classification and localization. Here the localization refers to the bounding box around the image. Here the boundary box around the cat image. So the object detection is going to be classification and together the localization. So here image classification assigns a specific label to the entire image, determining the overall content such as identifying whether an image contains a cat, dog or bird. So it uses several techniques, CNN and transfer learning. So now image classification versus object detection that we have seen in the previous slide. So it comes with the localization. So object localization here are providing a spatial information with bounding boxes around this object. So here the spatial information denotes the information on the geographical space, whereas the object detection is going to be combine the image classification and object localization, identifying and locating multiple objects within an image by drawing bounding boxes around each and assigning labels. So there are multiple techniques which have been used in object detection. So the first is going to be RCNN, region-based CNN, you only look once, single shot multi-box detector. These are the main techniques which is being used for object detection. So we have seen what is meant by object classification and types of the object classification and the differentiation between the object classification and object detection. Now coming back to the image classification, how image classification works. So these are the steps of the image classification. The first step is going to be on data collection and pre-processing. So for this, several images have to be collected and this serves as the foundation for training the classification model. So next comes to the pre-processing. So this includes resizing images to a consistent size, normalizing pixel values, applying data augmentation techniques. Here what is data augmentation techniques? So we have the rotation, cropping, flipping, brightness adjustment, sharpness adjustments, which all comes under the data augmentation techniques. So this increases the dataset's diversity and provides the robustness. And the next step is going to be on feature extraction. So the traditional methods which involves the edges, textures and colors, identification of the edges, textures and colors. However, the modern techniques leverage the CNNs, this is convolutional neural networks, to automatically extract the features from the raw pixel data during training. So the feature extraction techniques which involves in CNN algorithms in most of the places. And now comes to model training. The first step is going to be on choosing a model. So the CNN are the most commonly used models for image classification due to their ability to capture spatial hierarchiness in images. And next one is going to be the training the model, where we are going to split the model into training and the validation sets. So the model is trained on the training set to learn the features and the patterns that distinguish different classes. So now comes to the validation part. Here the validations is evaluated by the model's performance on the validation set to fine-tune its parameters, and that prevents overfitting. And next is going to be on the model evaluation and testing, where the trained model is tested on the separate test set to assess the accuracy, precision, recall and other performance metrics, ensuring it generalizes well to the even unseen data as well. And the last step is going to be on the deployment, where once the model is validated, the model can be deployed in real-world applications, where it processes new images and predicts their classes in real time or the batch processing modes. And here are the takeaways from this session. The first one is the image classification is a fundamental task in computer vision that deals with automatically understand the content of an image. And second task is going to be on image classification, differentiation between the image classification and the object detection. And third one is going to be on the steps of the image classification, which involves in data collection, pre-processing, feature extraction, model training, model evaluation, testing and deployment. Thank you. We'll discuss the interesting session next time.